Hello students, welcome to this session. So now I will discuss Unit 2 of the topic Applications of Epidemiology. So in the previous session I have told you the learning objectives of this topic. So this unit is Measurements in Epidemiology, covering competencies 7.4 and 9.2. And the objectives of this session are that enumerate the various types of measurements in epidemiology and calculate, interpret morbidity and mortality indicators. So let us recapitulate from an earlier session. The tools of measurement I had told you are rate, ratio and proportion. So what are these required for? To understand the magnitude of the problem. So to assess the frequency of the disease, I had told you three parts: frequency, distribution and determinants of disease. So frequency gives the burden of the problem or the magnitude of the problem. So we want to know how much of the population are suffering, how many people have been attacked, etc. So we study frequency for disease, disability, death and other health related events and states. So three basic measurements are rate, ratio and proportion. This I had covered in the earlier section. Just recapitulating for your understanding the next session. So these are the three measures. I'll just briefly go through it for recapitulation. Rate, ratio and proportion. So rate is a measure of occurrence of a particular event in a defined population within a time period. So this has a numerator, a denominator and a time specification, which is very important, and a multiplier. And numerator is a part of the denominator, that is the events occurring out of the total population. How many people suffering out of the total population? So numerator is a part of the denominator. And these are some examples. Ratio describes relation in size of two different quantities. So the numerator is not a part of the denominator because these two are different variables. And a time specification may or may not be present. These are common examples. And proportion, it again describes the relation in size or magnitude of a part of the whole population. So numerator is here a part of the denominator like a rate, but this does not have any time specification, and this is usually expressed as a percentage. So these are some examples. So now I start with the various indicators or measurements in epidemiology. So mortality, morbidity, disability, natality or fertility and measurement of various demographic variables like say gender, age, etc., which are usually expressed in percentage form. So in this session I will discuss mortality and morbidity indicators or measurements. Rest I will discuss as and when it comes in the subsequent sessions. So mortality indicators. There are few mortality indicators. I will discuss them one by one. First of all, crude death rate, which is the most basic mortality indicator, and it is crude, as you can understand from the term. So this is calculated as number of deaths occurring in a population in a given year divided by the total mid-year population. So mid-year population is the average population over the year because the year is a long period. So the mid-year population is taken as the denominator. For each year, the mid-year population is calculated from the census with addition and subtraction of births, deaths, etc., as I have discussed in the previous session. So mid-year population date is taken as 1st July of a calendar year. So this lacks comparability. Like crude death rate of two population we cannot compare. Why? Because the population structure and pattern may differ in the two population that we are considering. So one may have more of elderly, so their death rate may be more. One may have younger population which are not dying at that rate. So these two crude death rates cannot be compared. Hence we go into other advanced type of death rates which I will discuss. So I will just calculate one example. You can understand and subsequently you can work out your own exercises because these are very important for your exercises, practical exams, and also can come in MCQs. So the example is we have a village population 2000 people in that village and there were total 18 deaths in a calendar year. So now calculate the crude death rate. So crude death rate is numerator, you can see number of deaths in the year, so that will be 18. And the denominator is the total mid-year population, which is 2000. So 18 by 2000 into 1000, that is, we have a multiplier I told you. So ultimately it comes as 9 per 1000. So then we say CDR or crude death rate is 9. That is 9 deaths per 1000 population. So next is the specific death rate. So this is specific for a disease or specific for a group. So cause or disease specific death rate. So that is due to, suppose example we take due to tuberculosis. So tuberculosis SDR or specific death rate will be equal to the deaths occurring due to tuberculosis divided by the total mid-year population. So that means out of the total population, how many are dying due to tuberculosis? Similarly, we can have group specific death rates according to gender, age, whatever. So this is a gender specific death rate. Suppose we want to calculate for males. So that means it will give deaths among males divided by denominator will be per 1000 mid-year male population. Remember, here it is mid-year population, total population. Why? Because deaths due to TB can happen in the total population. But when we are calculating deaths among males, this will happen only obviously among male population. So the denominator is mid-year male population. Similarly, if we want to take a age specific death rate, suppose 10 to 19 year age group or adolescents. So that will be calculated as deaths of persons aged 10 to 19 years or deaths in adolescents divided by the total mid-year adolescent population, that is in this age group. Again, as I explained here, because these deaths, adolescent deaths will happen only in adolescent population. So this is the denominator. Now if we see one example, say the same village which has a population of 2000, where 1200 are males and 800 are females out of the 2000 population. And 20% of the total population are adolescents. And there some deaths have happened. I have told you 18 deaths had happened there. And out of these total 18 deaths, 4 had happened due to tuberculosis. 12 deaths had happened in male population. And 6 out of the total deaths had happened in adolescents or 10 to 19 year age group. So now let us calculate specific death rate for these different groups. So specific death rate due to tuberculosis, that is tuberculosis deaths are 4. So 4 divided by 2000 population, because I told you disease specific is mid-year population as the denominator, because all the total population is susceptible to developing tuberculosis. So 4 by 2000 in 2000 it gives 2. So SDR for TB is 2. Similarly SDR for male, I told you there are 12 deaths in males. So 12 divided by total mid-year male population, that is 1200. So 12 by 1200 into 1000. So that gives 10. So SDR for male is 10. Now specific death rate in adolescents, that is 10 to 19 year age group. So here again total adolescent deaths are 6 out of the total deaths. So numerator is 6. Now the denominator, I told you 20% of the total population are adolescents. So 20% of 2000, that means 400. So denominator is 400. That is in this village there are 400 adolescent population, out of which 6 had died during that calendar year. So 6 by 400 into 1000. So SDR for adolescents is 15. I hope this is clear to you. Next is case fatality rate. So this expresses killing power of a disease. That means out of the total cases, how many have died. So this is also related to virulence, that is the severity or how virulent the organism is or how serious the condition is, which can lead to death. So this is more used in acute infectious diseases. So case fatality rate differs from disease to disease according to the virulence of the organism. So this is calculated as total number of deaths due to a certain disease divided by total cases of the same disease, and this is usually expressed as percentage. So again, taking an example, in the same village with population of 2000, I had told you total 18 deaths had happened, out of which 4 were tuberculosis deaths, And now we find another data, that is total cases of tuberculosis were 40. So case fatality rate, I told you, will be, numerator will be total deaths due to that disease, tuberculosis, 4 deaths, and denominator will be total cases of that disease, that is 40. Into 100, it gives 10%. So case fatality of tuberculosis in this village was 10%. Next is proportional mortality rate, that is the proportional death due to a disease or in a population group. So for disease, it is calculated as number of deaths from specific disease in a year divided by total deaths. Remember, in this the denominator is total deaths that are occurring in that year. So out of the total deaths occurring in the year, how many were due to this disease? Or for population group, number of deaths of persons in the group divided by total deaths from all causes in all population. So the denominator is the same for both. Here the numerator is deaths due to a specific disease, here deaths in that specific group of population. And the denominators for both are total deaths occurring in the whole population due to all causes. So again, let us see the example. In that same village with population 2000, there have been 18 deaths in the year, out of which 4 were due to TB and 12 out of total deaths were among males. So now when we calculate proportional mortality rate for TB, so total deaths due to TB are 4, I have told you, numerator due to specific disease. So due to TB, 4 deaths. Out of the total deaths of all causes in the year, in the whole population, that is 18, I told you, total deaths were 18. So 4 by 18 into 100.